Well, so far we have discussed the fact that uh, how to construct, here as you can see in the last video, that in the while group presentations and the while group transformation, how they change our the and what this thing, and then from there the affine Kashmiri algebra and from then onwards, we'll try to see the full algebra. It's basically surprisingly simple to state in terms of SU2, like commutation relations. Okay? Because no SU2, this thing type of beta. And so here it relates as TMA, TMB commutator is I epsilon ABC, TCN plus N, plus this NK delta AB delta M plus N0. So if you just ignore this part, this is just the this is two algebra. Here this mn takes the value from this 0 plus minus 1 plus minus 2 and so on. The undermine the constant k is at the heart of this Kachmuri algebra. So it's useful to adjoin to this algebra an operator L0 to understand it better. So which counts the subscript, that is like L0 TNA is basically N TNA. It's just like splitting out the N from this TNA. That's with the action of this thing. Now, if you do that thing before leaving the SU2, we note the existence of another carton-like matrix, which is basically having the Hessian determinant, right? Which is the A12, is 2 minus 1 minus 4, 2. So the Serre presentation actually applies equally well and generates a new infinite dimension algebra, which is the twisted affine Kachmiri algebra. So now coming back to the general case, the identification of the generators applies equally well when arbitrary ranks are in the algebra. So though initially thought it's actually applicable only in the infinite dimension algebra, but one can certainly use this kind of presentation for in the finite dimension in the algebra. So that's what we have called as R dimension or the rank R. Now the elements belonging to the root delta are now the artful commutators, okay, and that involve one A0, and we identify them with T1J, where J runs from over this all the R levels of this Cartan subalgebra. Now one needs to identify the generators with subscript equal to 1 in order to generate the full algebra. So as we have seen here. And the null root is defined in terms of the marks as in delta equal to I equal to 0 to R deformation, Ci alpha. So if you remember marks and all those things are there. So this is the same marks we are considering here. And to ensure it has a 0 length and is orthogonal to all the other roots of the Lie algebra, that is basically delta alpha inner part is 0 for all the choice of I equal to 1 to R. And the procedure is of course more algebraically tedious, but the result is to produce the general commutation relations, which is of this following form. And here, if you remember the C2 thing, this was epsilon ABC, but for any generic algebra, which is not a C2, then your structure constants will be defined, and for that we have this FABC, and we have this invariant term. And this actually, as I mentioned just a few seconds back, is obtained by simply replacing epsilon ABC with a more generic structure constant function FABC and go. So now let's talk about a little bit about the representation theory. So the representation theory of affine Kachmiri algebras is constructed in a very similar way as the Lie algebra, except that all are basically infinite dimension, and there's a difference here. For example, affine SU2, the states are labeled by two integers A0, A1. So if you remember the SU2 is like one integer, the rank is 1, but also SU has this extended Cartan matrix, so it's now the elements are basically just two integers, A0, A1. So when both A0, A1 greater than equal to 0, the state lies inside or on the walls of the while chamber, and that we have also discussed earlier. And it can be used to label and irreducible representations. The rest of the states in the representation are obtained by subtracting the positive roots from the highest root state and the usual case. So in the input basis, the positive roots are given by the row of the extended Cartan matrix. For example, the alpha 0 is 2 minus 2 and alpha 1 is basically minus 2, 2. And the linear combination with the co-marks, which is C0 tilde 0 plus C1 tilde A1, is invariant under the subtraction by the roots because the co-marks are the components of the zero eigenvector of the Cartan matrix. So it doesn't alter anything. So it's called the level of the representation. In this case, it is just like we can define for A equal to A0 plus A1 and can be served as partial level for the presentation. So we can subtract alpha 0, A0 times from the highest state and alpha 1, A1 times, and that's it actually manifestly in the construction. And this results in a zigzag pattern for the infinite number of states in the representations. So this zigzag direction actually denotes subtraction by alpha 0, alpha 1. And to keep track of these states, weights are assigned a null weight. Okay. And these weights actually assemble an infinite number of SU2 representations. So when k equal to 0, this algebra is rather trivial to realize, introduce an infinite number of oscillators and each of which transforms an SU doublets. And so we can write down AMN commuters at time at and what AMN is just 0 plus minus 1 plus minus 2. So you can see and those many, CP algebras you can construct. And then define the generalized Swinger representation TMA half AJ plus n dagger sigma A AJ, J answer minus n plus infinity, and seem to satisfy the Kashmiri algebra with k equal to 0. We also have L0 equal to J AJ dagger AJ. Oscillator representations with equal to not equal to 0 are less obvious, of course, but C numbers generally occur in commuters of quadratic combinations when normal ordering is invoked. So, in field theory, the way normal order, this thing, the annihilation operator will always appear on the right. So, you want dagger A1 input, you can just normal order there, you can write it down like A1 dagger A1 and A2 dagger normal order operator. So, this is the way one can define. So, this part actually the Serre presentation and the other part that is a very big one. So maybe one of the projects may include this thing, and we can have a much more detailed look